Hi guys! As promised in this video, we will learn how to graph a linear equation. Remember that a linear equation is something that when you graph it, it makes a nice straight line. So we should be drawing a bunch of straight lines today. I will show you one example of each type of linear equation. We do want to make sure that we are drawing accurate graphs. So make sure to go grab some graph paper. If you don't have graph paper, you can print some from a free website. If you go to my virtual classroom, on the bottom of the bookshelf is a piece of graph paper that will take you to a website where you can print your own graph paper at home. Okay, we're going to start today with how to graph something in slope-intercept form. Slope-intercept form, if you don't remember, is y equals mx plus b. When you're graphing something in slope-intercept form, you always want to start by graphing the y-intercept. The y-intercepts can be found at the end of the problem. Don't forget, a y-intercept is a point. It's a dot on a graph. So my y-intercept is written as an ordered pair, 0, -2. The letter that we use to represent the y-intercept is a b. And so I've given you a b jumping up and down to remind you that the y-intercept is where the graph crosses the y-axis, which is the axis going up and down. And so when I'm graphing this point, I want to go up or down to figure out where the dot goes. In this scenario, I will be going down to the -2 and putting a dot. This is my starting point. So again, we're starting with the y-intercept. From here, I need to know what direction to go. I have a dot. Do I go up, down, left, right? Like where do I go from here? And we get the direction from our slope. Now, slope on its own doesn't really do anything. You can't start with slope because slope is telling you where to go from a pre-existing point. So that's why it was really important that we already drew a dot so that we know, okay, now I'm going to put my pencil on my green dot and I'm going to do my slope. Slope is written as a fraction. Even if it's a whole number, you got to write it as a fraction so that you can see that concept of rise over run. You need two numbers. You need a rise number and a run number. In this problem, my slope is 3/1. So I'm going to put my pencil on the green dot and I'm going to rise +3 up 3 boxes, and I'm going to run to the right 1 box. And that's where I put my new dot. Unlike an ordered pair where you're starting on the origin, for slope, you always want to start on a pre-existing point. Rise 3, run 1. When you're graphing a line, I do like you to draw more than just the 2 dots when possible. So I would like you to keep going with your slope. I'd like at least 3 dots. You can keep doing the same slope. Rise 3, run 1, rise 3, run 1, or every slope can be written in 2 different ways. The original way, and then for the second way, you can change the sign of each of the numbers. So a slope of +3 over +1, or rise 3 and run 1, can also be written as a slope of -3 over -1. Rise -3, run -1. That will get me the same directions. So I can keep rising 3 and running 1, or I can rise -3 and I can run -1. Notice that these lines are collinear. They still all connect together to make one straight line. Once you have at least 3 dots, go ahead and connect your dots together to make that straight line. You do need a line. These are linear equations because they make a line. So just dots is not okay. This is our example for graphing slope-intercept form. Next, we will learn how to graph point-slope form. In point-slope form, Similar to slope-intercept form, we cannot start with the slope. The slope only works if we already have a dot on our graph.
Hello.
So I have to start by finding the point, which I can because, again, this is called point slope form. So I should be able to find a point. As a refresher, for point slope form, this is the original formula, okay? And so our point is gotten from the x1 and the y1. That's where we get our ordered pair from. Now, you'll notice that in the original formula, which I wrote in red, the x1 and the y1 are being subtracted. So when you're trying to find your ordered pair, you have to ask yourself, what number am I subtracting from x? Well, I'm subtracting the number 4. What number am I subtracting from y? Well, I'm subtracting the 5. So when you're writing your ordered pair, it's always going to have the opposite symbol from what was in the original equation. If it was being subtracted, you'll write a positive. And if it was being added, you'll write a negative, because adding is like subtracting a negative, okay? The other thing I want you to notice is that even though in the equation the 5 was first and the 4 was second, in my ordered pair, I wrote the 4 first and the 5 second. That's because in an ordered pair, you always need the x to be first and the y to be second. And my 4 was attached to my letter x, and my 5 was attached to my letter y. So you also want to pay very close attention. What number is with the x, and write that first. What number is with the y, and write that second. Once you have your point, your ordered pair, then you can graph it. And that is your starting point, right? So we always need a dot to start with. Now that we have our point, now we can use our slope. Slope is found in the same place it was for slope-intercept form. It's right in front of the letter x. So in this scenario, it's -2/3. Now notice, and we've talked about this a couple times already, the negative sign needs to be attached to one of the numbers. So you don't want to float it in front. You need to make an executive decision. I'm going to make the top number negative. That means that the bottom number is positive. So my slope in this problem, I'm going to rise -2, and I'm going to run +3. Notice that your line would be sloping downward. That's good. When you have a negative slope, you want it to be sloping downward. You want it to fall down. Negative slopes fall down, positive slopes rise up, okay? Now, we said on the last problem, we can always write our slope in 2 different ways. So the other way to write this slope would be, instead of attaching the negative to the top number, I could alternately attach the negative to the bottom number. If I attach the negative to the bottom number instead, now my slope says +2 for a rise and -3 for a run. +2 for the rise and -3 for the run. And again, notice that all 3 of my dots are lining up to make that nice straight line, a linear equation. This is how to graph point slope form. We've got one more type of linear equation, and that is standard form. Now, standard form, it doesn't have a point and a slope or an intercept or nothing like that, right? We call it standard because it just looks pretty. And so for standard form, we're going to have to do a little bit of math to find some points to graph. And specifically, we're going to be finding the x and y intercepts. The really cool thing about x and y intercepts is that one of the numbers in the ordered pair will always be the number 0. So for the x-intercept is where the line is going to cross the x-axis, and the ordered pair for that is x, 0, which means that my y-coordinate will be the number 0. That's really helpful. And similarly for the y-intercept, it's where the graph crosses the y-axis, and for a y-intercept, the x-coordinate will always be 0. So it's really, really helpful that those numbers are 0. Here's the example we're going to graph. So again, we're going to need to do a teeny tiny bit of math, little bit of work. We're not just going to pull numbers out of the problem. I'm going to start by finding my x-intercept. And to find my x-intercept, what I do is I make the letter y 0, right? Since the y-coordinate is always the number 0, I can just change the letter y in this formula to 0. Now this is really, really easy math, right? Because 2 times 0 is 0, x minus 0 is x, and I get my x-intercept is 6. Now I'm not just going to write x equals 6, and I'll talk about why we don't do that in the second video. But so I write an ordered pair, 6, 0. That's my x-intercept. Alternately, for my y-intercept, since the x-coordinate is 0, I can go to my original equation and I can replace the letter x up here with the number 0, which essentially just makes that letter x go away, right? It disappears. I would need to do one more step of math. I would need to divide both sides by -2, and I get that my y-intercept is -3. But again, we don't write y equals -3. We write an ordered pair. Since it's just one point, it's a dot, 0, -3. Okay? So this is the math that you need to do to find your intercepts. Notice that the number -3 was not anywhere in the original problem, right? So we can't just pull it out of the original problem. You can do the work, plug in a 0, or you can do something called the cover-up method. The cover-up method is just a faster way to find your answer. When we plug in a number 0, it essentially makes that variable disappear. And so instead of plugging in a number 0 and writing it down, we can just cover it up and then do the math from there. So if I'm doing x minus 2y equals 6, and I want to find my x-intercept, I'm going to cover up the other variable so that I can only see the letter x. And I don't even have to do any math on this one. This one literally says my x-intercept is x equals 6, and that's my x-intercept. If I want to find my y-intercept, I cover up the other letter, so I still want to see the letter y, so I cover up the letter x, and now I see a very simple math problem, -2y equals 6. In my head, I can figure that out. I divide by -2, and I get -3. So this is called the cover-up method to find your intercepts. Just make sure, again, when you're done, that you're writing your intercepts as ordered pairs. And the reason why we write them as ordered pairs is because they give us a dot, a point. The point for my x-intercept will be on the x-axis at the +6, and the point for my y-intercept will be on the y-axis at the -3. Now for standard form, since we don't have a slope, since we only have intercepts, we can only draw 2 dots. And again, one dot should be on the x-axis and the other should be on the y-axis, and then you just connect them together. This is how I want you to graph standard form, by finding your intercepts. And make sure to write them as ordered pairs. This concludes our first video. Your homework from this video is on a worksheet.